Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 40 in our epic, in our legendary, new and improved series of Arduino tutorials. What we are looking at today is the homework that I assigned you in lesson number 39, and what that homework was to take your motor controller, the basic motor controller which you built in lesson number 39, lesson number 37, I guess it was, and then to this time around control that motor with two switches. What you were supposed to do is the motor was supposed to start in the off position. If you press the button once, it's supposed to turn on slowly. Every time you press that button, it was to go faster and faster and faster. If at any time you press the button on the left, it was to go slower, slower, slower. If you start at 0 and press the left button, it's supposed to run backwards. And then each time you press the left button, it goes faster, faster, faster in the negative direction. So your assignment was to start with the motor off and then to smoothly transition between full forward speed and full reverse speed by pressing either the up or the down button. Did you do it? Okay. Let's ask, did you really do it? I will ask you, part of your grade would be, should I be grading your homework? First of all, did anybody even do the homework? Did anybody even try the homework? I hope so. How I would grade it would be, like if I come in and the first time I press this button, does it turn on? And does it turn on to the slowest possible speed? If I then press the other button, does it turn back off? And if I press the other button again, does it reverse to the slowest possible speeds? I want to see smooth operation. Now, the natural thing would be to have some concept like motor speed, and every time you click the up button, increment motor speed by 10, and every time you click the down button, decrement motor speed by 10. But what is the problem? The problem is around 0, the motor doesn't run. You've got to get to about 100 before it turns on, and this is the analog write, the analog write between 0 and 255. If you're not writing a speed to that speed pin of 100, it's not going to run. And you don't want to leave your user sitting there poking that button trying to get it to turn on. So one of the things that we have to do, and I hope you did, and I hope you will comment and let me know how you did, is you've got to start by doing your paperwork, all right? And one of the things that I see over and over among my students and the people that I'm trying to teach is they jump right in and they start trying to build the circuit and code things before they have a roadmap, before they have a template, before they have a game plan. In the old days, we would call it a flow chart, sort of a picture of how this thing is going to work. And so let's jump in and do that. And you can do it along with me, but what I want you to see is I want you to see about how I think about a problem like this. Okay, so let's start with what we were given. We were given that we would have two buttons, all right? We would have two buttons, and this would increase the forward speed of the motor, and this would either decrease the forward speed or increase the negative speed. So we have this concept of motor speed, which I will call M speed. And the easy thing to do would just be every time you press the button, increment motor speed. Every time you press the left button, decrement motor speed. And it would work for most of the cases, but in fact, it would not work in these important middle cases. And so let's draw a graph here and kind of think of what we want. I always like to draw a graph. I like to start with a picture. And if there's anything I want you to learn is if you can make it work on paper, you can make it work in the circuit in the Arduino. But if you try to jump in and make this work in the circuit before you have it working on paper, the chances of it working are very small. So where do we start? And let's just say that this is our M speed. This axis up here is our M speed, motor speed. And what's something that we know about motor speed? Well, that we can go full blast in the forward direction, which we can call that like 255, and then we can call this down here minus 255. Now we understand that we can't write an analog write of minus 255, so we know what this means conceptually is 255 in the negative direction, and this is 255 in the positive direction. So let's start here at this conceptual 0. When the program starts running, we need to be at 0. Now let's just imagine that we pressed this positive increment button. Well, what you would do is you would think, your tendency would to think, okay, add 10 to m speed, but if you're at 0, that's not going to work. What you got to do is, if you're at 0, you got to come all the way up to 100. Now that's for my motor. Maybe for your motor it would be something different. Now once you're at 100, you should be able to increment by 10, and then you should be able to step all the way up to 255. So this is going to be, not to scale. We're just going to kind of skip the ones in the middle. And then when you get here to 250, if you add 10, it's going to go to 260, but you've got to peg it at 255. You've got to not try and write a number greater than 255. And so what are we starting to talk about here? Some if statements. So what I would need is like an if statement. If m speed is greater than 255, set m speed equal to 55, right? So don't let it go above 255. So as you come up, if you keep pressing that button, you've got to hold it at 255. Similarly, if we're coming in the negative direction, if we're at 0 and hit the decrement, your tendency would be to put it at minus 10, but the problem is at minus 10, it's not going to turn the motor on, so you've got to come to minus 100. And then at that point, with each additional push of the button, you could increment by 10, and then it's going to be moving smoothly. So this is pretty clear. And then similarly, when you get to minus 250, and then you subtract 10, it's going to go to 260, but you've got to kind of nail it and hold it at minus 255. So I would need another if statement. If m speed is less than minus 255, if you start trying to wander off down here, you want to set m speed equal minus 255. So that's going to keep my values between 255 and minus 255 with those two if statements. But we still got to deal with this problem here. So we see that if I try to increment to 10, I've got to go all the way to 100. If I try to increment to minus 10, I need to go to minus 100. Similarly, if I'm at 100 and I decrement, I don't want to decrement to 90. I want to decrement all the way back to 0. So what does this mean? This means that I don't ever want to have a value between 0 and 100. I want to go all the way to 0, or I want to go all the way to 100. So let's handle this going up problem. And the going up problem is, if m speed equals 10, you want to set m speed equal to 100, right? So if you try to go to 10, no, you got to jump to 100. Also, if m speed is equal to minus 10, you want to make m speed jump all the way to minus 100. So for these two special cases of 10, jump to 100, and then minus 10, jump to minus 100. So that will take care of those. But this is the other problem. The other problem is that if you come in and you go to minus 90, you really don't want to be at minus 90, you want to be at 0. Okay, if you come here and you want to go to 90, you really want to go all the way to 0. So this would be, you're sitting at 100 and you decrement to 90, then you want to go all the way to 0. And similarly, if you're at minus 90, you're at minus 100 and you go to minus 90, you want to go all the way to 0. So far I've got 1 if statement, 2 if statements, 3 if statements, 4 if statements. Now I've got to handle these two here. And the problem that you can see, maybe you didn't see, but I'm going to go ahead and tell you the problem that you can see. If you go to 250 and you increment, you're going to be at 260, and then you pin it down to 255. When you're coming down, you're going to be 55, 45. You're going to be not at 100. You're going to be at 105. And then when you decrement, you're going to be at 95. So the two cases you worry about is if m speed is 90 or 95. Because coming down, you could end up at 95. Then you want to make m speed equals 0. So there's two you have to worry about. On the way up, you got to, or on the way down, when you didn't go past it, you got to worry about 90. If you go past it and come back to 255 because of this other rule, then you've got to worry about the 95. Similarly, here, if m speed is equal to minus 90 or minus 95 for the same reason, you want to go ahead and set it at 0. And here what you did was you're going to set m speed equals 0. Does this make sense? Please stop and put questions if this doesn't make sense. Okay, I think that you understand that you don't want to go above 255, so you understand that if statement. You don't want to go below minus 255. You understand that if statement. If you are at 0, you don't want to increment by 10. You want to go to 100, so you understand this one. This was the one that m speed is 0. Okay, so if you are at 10, you go all the way to 100. If you're at minus 10, you go to minus 100. You understand those. It is the 90 that would be coming down from 100. You would end up at 90, go all the way to 0. Or if, because of this strange other condition, if you were at 105, you would end up at 95, and in that case, you would want to come back to 0. Okay, so we are going to have 1, 2, 3, 4, 5, 6 if statements that would handle these kind of special cases. So let's go in and let's start working on our circuit now. And I will be honest with you, this is I think this is a lot more complicated than you thought it was going to be when we were just talking about it. And so let's start by putting these switches in here. Remember on these switches that the pins that are pointing towards each other, the pins that are pointing towards each other are already connected together, so they need to be in a common column. The pins that are pointing towards each other need to be in a common column. So I am going to put those up here. I'll put one switch there. Get it plugged in good. These switches actually fit in a breadboard better than most, but they're still kind of hard. The pins that are pointing towards each other need to be in a common column. If you do not understand that, go back to lesson number 34, and I show you the easiest way to use these push button switches. All right, now we know that one pin of the switch needs to go to a digital pin, and so I'm just going to come down to pin 8 because it's available. And then the other pin needs to go to a ground. The other pin of the switch needs to go to a ground. And so I'm going to come down to this common rail, this ground rail, which we set at the second to the bottom row. All right, you see this little negative rail? We set that up. If you don't have the motor set up, you need to go back to lesson number 37, where we showed you how to do this. All right, now I'm going to hook up the other switch. The left pin is going to come down to, I need a little longer wire for that one. The left pin is going to come down to pin 9 on the Arduino. Okay, so the two switch pins are pins 8 and 9, which you can see there. And then the other one, I similarly need to ground the other pin of the second button I need to put into that ground rail. All right, I think I have everything hooked up. And so now the first thing that I want to do is I just want to see if those buttons work, right? I want to get the buttons working because there's a lot of code here. And what I want to do is I want to start by getting the buttons working, because you can't go in and try to debug the motor if your basic button functions aren't working. And like I say, lesson number 34, we show you basic button function if you're not following along. I guess I should say if you're not understanding what I am saying. Lesson 34 will show you how to set up the buttons. Let's come to a nice code view. This should be pretty good. This code here, I am starting with where we left off in lesson number 37. And so how do you go to lesson number 37 to catch up? Well, you come to the most excellent toptechboy.com and you look for Arduino tutorial number 37, and that will show you how to hook up the circuit, and it will show you the code that we're using as a starting point. So if you haven't done that, you need to go and get caught up with where we are. Okay, so with that, you can come back here and again get a code view. And now we're going to incorporate the buttons. Well, what did we add? We added two buttons, so I need an int, and then I'm just going to say button pin 1. And what was button pin 1? That went to pin 8. And then I'm going to have an int, and I'm going to have button pin 2, and that went to Arduino pin 9. Well, if I have a button pin 1, I need a button 1 value, and that's I'm going to read. I'm not going to put something in there. I'm going to read it. And then I'm also going to need a button 2 value. If I'm adding two buttons, I need to do some more pin mode. So I'm going to do pin mode, and I'm going to do, I've got to keep looking at this, BP1 and BP2. So BP1 is an input because I'm going to read from it, and then pin mode. BP2 is an input because I'm going to read from it. Now, if you remember in lesson 34, I showed you how you can use these switches without an external pull-up resistor. And the way you do that is, even though these are inputs, when you do the input, it brings the pull-up resistor in. Now I want to turn those two pins high, even though they are input pins. So I will do a digital write, and then I will do button pin 1, make it a high, and then I will do a digital write, and then I will do a button pin 2, and it will be a high. And so now I should be ready to read off of those. I should be ready to read B1 val and B2 val. So how do I want to start my program? Well, one thing is I do need to clean this up. Remember in lesson number 37, we were kind of kickstarting the motor. I want to take that kickstart business out, and then I want to take this delay out, and then I'm left with the three basic commands that will run the motor. dir1 and dir2 are the direction pins, and if we have them like this, it runs one direction. If dir1 is high and dir2 is low, it'll run like this. If dir1 is the other way and dir2 is the other way, it will run the opposite way. So let me try again. dir1 is low, dir2 is high, it runs one direction. dir1 high, dir2 low runs the other direction. And then you do an analog write on your speed pin of motor speed, and that will set the speed. But for right now, we want to read those two buttons, and so I am going to say, always making sure I am looking at the right thing, B1 val and B2 val. So I have button 1 val. I am going to read it, so it is an analog read of button pin 1, and then I'm going to do button 2 val is equal to analog read button pin 2. So I'm going to get those two values, and then I'm going to print them out just to make sure that I'm reading them correctly. In this configuration, we expect if the button's not pushed for it to be sitting at a 1, and when we press the button, we expect to see it at a 0. So let's do some serial prints. Serial.print, and I want to start by just saying button 1 space, and then I want to do a serial.print. And what is button 1? Well, it's going to be B1 val. And then I'm going to do a serial.print, and then I'm going to do a string space button 2 space as a string. And this will be the last thing, so I'll do the print line to take it to a new line. Serial.println, and I'm going to do B2 val. And so this should show me whether I have the buttons working, because nothing's going to work if the buttons don't work. So let's go ahead and download that. Yes, it downloaded, and now let's call up a view that you can see these things spinning by. Okay, so it is saying something very strange here. Let me go to a better view. What if I come over here? Can you see it? Yeah, okay. So you see, this is very strange. Look at that button. Button 1 and button 2 are giving me crazy things. Okay, let's look and see. We made a horrible mistake here. When you read from a button, were you screaming at me? That's digital read. That is not analog read, that is digital read. You see why we check our buttons, we check our code as we go? Actually, I did not do that mistake on purpose. That was a real mistake. But what I want you to see is how to debug, and you don't want to write the whole program and then the thing doesn't work. We're getting the buttons working. So what we would expect is we would expect a 1 on both of those. So we download it again, and look at that, a 1 and a 1. Now the real question is, when I press the left button, does button 1 go to 0? And in fact it does. Look at that, boom, beautiful. Now if I press button 2, does button 2 go to 0? Boom. What do we know? Button 1 and button 2 are working. Now I can move forward with confidence in what I am doing. Okay, so let's sort of think. The first thing that we want to do is we want to read the button values, which we have done. Now, before we worry about the simple cases, the simplest thing, remember we set up a variable up here, motor speed. Motor speed needs to start at 0. So when you start the program, motor speed is 0, the motor's not going to be running. Now, before we start dealing with all of those special cases, what we need to do is we need just to do the simple thing. And that is, if button 1, if button 1 val equal 0, what does that mean? That means someone pressed the button. And what is that? That's the decrement. That's the slower one. So in that case, m speed is equal to m speed minus 10. Now we will come in later and we will adjust for all the special cases, but to start with, let's just say if you press the decrement button, speed goes down by 10. Now we want to delay, because if I press that button and it's going real fast, it might read 50 button clicks, and so we've got to slow it down. So I'm going to put a delay, and how much? Delay time. I've got to define delay time up at the top now. And so that is a new variable, integer delay time, and let's just set it at 1/2 of a second so it doesn't make too many readings too quickly. Okay. So if button 1 is pressed, I'm going to subtract 10, and I'm going to wait so it doesn't just sit and keep reading a bunch of button presses. So that looks good. What else do I need to do? Well, if button 2 val equals 0, in that case, what do we want to do? Well, the simple thing before correction is we want to make m speed equal m speed plus 10. Does that make sense? So left button, we decrement speed. Right button, we increase speed. So those are the two nominal things. We also want to put the delay in, so when I press the button, it doesn't read a whole bunch before I can get my finger off of it. It also probably would help to debounce the switch a little bit if you have a bounce problem with the switch. All right, now we have to take care of those special cases. You never want to analog write a value greater than 255, so we've got to peg m speed so that it doesn't go beyond 255. So that is the first case. If m speed is greater than 255, then what do we want to do? Well, we want to peg it to 255. So m speed, we just say you go back and you equal 255. Okay? What is the other one? If m speed is less than, if it's below minus 255, that's the same problem on the other end, then what we want to do is we want to say m speed equal minus 255, if I am thinking about this right. So now we've got those two outside ones taken care of. Now, what were the other ones? So I think we said that there were several of these that we had to take care of. So let's look at the other ones are around 0, and we've got to think about what to do in the cases around 0. So first of all, what we know is if m speed equal 10, so that is you're at 0 and you tell it to speed up, it's not going to run at 10, right? So if you're at 0 and you tell it to speed up, you're going to have to make m speed equal to 100, like that. Similarly, if m speed equal minus 10, what is that case? That is, you're sitting at 0 and you tell it to go backwards. It can't run at 10. You're going to have to give it a better value. So m speed is going to be equal to minus 100. So that takes care of those. Now the other one is when you are making that transition, let's get back over here. On the way down, remember, if you're making the transition from 100 or 105 down, you want to go all the way to 0. So if you're at 90 or 95, you want to go all the way to 0. If you're at 90 or 95, you want to go all the way to 0. So let's put those in. If m speed equal 90, or, which is the bar, which is above the slash, above the backslash, or m speed equal 95, what do you want to do? Turn it off, man. You can't run that slow. You got to go all the way to 0. M speed equal 0. Oh man, look at this. I didn't put the colon up there. Semicolon. Okay. So now, if on the negative side, if m speed equal minus 90, or m speed equal minus 95, similarly, in those cases, you want to make m speed equal 0. Like that. All right, So we've taken care of all of the special cases, I do believe. Now what I want to do is to check this. Now again, we always want to be doing, I want to check this, and what we always want to be doing is, sorry, okay. What we always want to be doing is kind of checking our code. So let's go back to this view where you can see, I think I have a better one than that, where you can see the code. Is this it? Okay, yeah, you can see the code there. Now we know our buttons work, so we really want to be looking at button speed, or yeah, motor speed. So we'll come in here, and we're just going to print out. Instead, we are going to be printing out motor speed, and then we will print ln speed. So before I write these things, I want to make sure that my motor speed looks good. And so let's download that. Oh no, what happened? If b-val equals 0, big if. Were you guys yelling at me? Little if. Hopefully I didn't do that over and over. I did, didn't I? If. Were you guys yelling at me? Hopefully you were. Okay. Hold your breath. Oh, no, denied. Forgot my semicolon. The real problem is you guys are not holding your breath. Another one. What is this? Oh man, we were not putting in the things that we needed to put in our semicolon. Okay, this time for real. Every last one of you, hold your breath. Oh, this did not need a close there. That was craziness. Okay. Right, you see we had a closed parentheses where we didn't need one. I hope I was not doing that. All right, let's try it this time. It's going to work this time. Yes. Okay, so now we start with a motor speed of 0. Is that what we expect? Yes. If I press the right button, and let's see, I'm going to get further out of your way so you can see me. I'm going to press my right button, and I should see motor speed. It's going to try to go to 10, but then the special case should send it to 100. Okay, boom, 100. Now if I press it again, what? 110. If I press the decrement, it should go to 100. Decrement takes it to 100. Another decrement should take it to 0. Boom. Now if I go 100 and then I just keep pressing 110, and then let's just go all the way up to 255. We want to make sure that it pegs at 255. Okay, now it's pegging at 255. Now when it comes down, 45, 35, each button is changing it by 1. Okay, it's doing very well. Okay, coming on down. Now this is the thing, you see, this was that special case. You see how I'm at 105? When I decrement it, it's not going to go to 100, it's going to go to 95, which is why we had to have both of those if statements. And it goes to 0. Boom! Let's check on the decrement. If I hit decrement now, it should go to minus 100. Whoa, that was crazy. It went to minus 255. So I've got a crazy mistake in there. So somewhere I have got a crazy mistake in here, and that thing just absolutely pegged out. Let me hit a reset here and see if I can get that thing to come back. Okay, it's at 0. And then if I hit decrement one time, it goes all the way to minus 255. So let's see what the problem is. We say motor speed is equal to motor speed minus 10 if I hit button 1. So I did that, and so my motor speed is at minus 10 if B2 val is 0. Okay. Okay, so let's look at these special cases. My M speed would be, this was the mistake. I said minus If M speed is less than minus 55, that should be minus 255. That's certainly one mistake there. And then M speed, if M speed is 10, M speed is 100. If M speed is minus 10, M speed is minus 100. That looks good. If M speed is 90 or 95, you go to 0. If M speed is minus 90 or minus 95, you go to 0. And so that looks pretty good. Let's try and see if that fixes that. But that was kind of still, I'm a little bothered. Okay, so I'm going to hit the negative button one time. I'm at minus 100, minus 110, minus 120. Coming back, that's looking good. Okay, minus 100, now it should go to 0. Goes to 0. Minus 100, let's take it all the way to minus 255 and see if it pegs at minus 255. Looking good. Okay, it pegged at minus 255. Now it comes back to 245. And now we'll see if making the transition around 100 works. Okay, at 115, it goes to 105. One more, 95 goes to 0. Boom. Okay. Guys, you see if you can get your button working and then your motor speed working. Can you imagine those two problems that I had, those two mistakes? If we'd gone all the way and then wondered why our motor was not running correctly, we would have never figured it out. Okay, so now we have a good motor speed at this point. We have a good motor speed at this point. But what we have to see is we have a positive motor speed and we have a negative motor speed. So let's think. First of all, if M speed if M speed equal 0, if motor speed is 0, what do you want to do? Well, you want to analog write, and you want to analog write to speed pin, And what do you want to write? You want to analog write a 0, because if motor speed is 0, you want it to be off. So that's one case. If motor speed is 0, you want it to be off. Okay. Now, if motor speed is greater than 0, what do you want to do? Well, you've got to tell it which direction. And this one is pretty easy. It's going to be the forward direction. And so it's going to be pretty much this code that we had down here, which I will copy, and then I will delete it, and I will put it here. So this is the forward direction where dir1 is low and dir2 is high. I'm just simply going to write speed pin M speed. And remember, M speed is good now. I've done all those special cases. So I have it taken care of. If M speed is 0, we're good. I have it taken care of. If M speed is greater than 0, we go in the forward direction and we go a speed of M speed. Now, if, what is the other case? M speed is less than 0, what do we want to do? Well, we're going to do almost exactly this. So I will copy all of this. First thing we got to do is take care of the direction. If motor speed is less than 0, we want to run backwards. So to run backwards, what do? We set dir1 high, and we set dir2 low. Now remember, M speed is negative. You cannot analog write a negative number. That negative was to tell us we wanted to go backwards. We took care of that. We're going backwards. So on M speed, we're going to write the absolute value of M speed. Does that make sense? We took care of the less than 0, the negative here, and now we just write M speed. So now I need to come back over here to my little motor, my excellent little motor, and then we are going to make sure, let's see, I think I'm going to keep it on this view for just a second. Make sure your power supply is on and everything is hooked up according to your earlier lesson. Lesson number 37 was your basic motor controller. Now let's download. Oh, what is it complaining about? Ah, I didn't put a semicolon. Were you yelling at me? I hope so. Okay. Oh, yes. Okay. And now if you look at motor speed, the motor speed is 0. Why is the motor speed 0? The motor speed is 0 because, and I'll scoot this over a little bit, the motor speed is 0 because, right, we started in the program, we said start off with a motor speed of 0. Now, if I press this, let me make sure that that's not hitting my little wires. Get my little wires out of the way so we don't have any obstructions. Now, if I press that increment button once, it should run in the forward direction. If it can really run at 100, I played with this motor, so maybe I've gotten it messed up a little bit, but let's do that. And okay, good news, it's trying to run. I'll give it a little help. Okay, this motor is just not going to quite run at 100. Maybe it is with a little help. But if I make it go a little faster, okay, at 110, it's pretty happy running. Okay, let's decrement down to 100. Okay, now if I decrement, it should go to 0. And look, it goes to 0. Now if I decrement again, it should go to minus 100, and it should run in the opposite way. Okay, I'll give it a little more help, minus 110. Okay, and at minus 110, it is running counterclockwise. Counterclockwise at minus 100, stop. And then when I go this way, increment, it's running positive. Okay, so this is working. All right, this is working. It's just when I first started working with this motor, I could start it at 100, and now kind of in this position or under these conditions, it won't quite. It's more like 110 or 120, but let's go ahead and see if this will work. I'm going to increment it up. Man, it is starting to run faster and faster and faster. Maybe I should go to the full view here. Okay, so I've got faster, 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 faster. And now we are all the way up to full speed. We are all the way up to full speed. Boom, this thing is really, really, really working. Now let's start decrementing. It'll start by going slower, and I can noticeably perceive it going slower. And then we're going to get back down to 115. It is barely running. 105, it is barely running. And then I go to 95, it goes to 0 and it stops. And now if I decrement again, it is trying to run in the opposite direction. Give it a little help there. Okay. And then it's going faster and faster and faster in the negative direction until it's going in the negative direction a maximum amount at 255. And then in that negative direction, I can start slowing it down. Boom! Did you see this? This thing is working like a champ. Okay, guys, I think when I gave you this assignment, it probably seemed a lot easier than what it turned out to be, because there were a lot of special cases that we had to take into account. A lot of special cases that we had to take into account. Let me know your comments down below. Did you guys get this working? If I'd been giving you a grade, would you have gotten an A? An A plus or 100 would have been the first button push it would have run. Okay, on mine, my algorithm was right, but it didn't run on the first button push because really I should have tested a little more carefully, and mine doesn't quite run at 100. And so I would give myself probably a 92 on this because I should have determine that value a little bit more. I don't ding myself because it doesn't run the first time, because that's part of learning, is you're going to make mistakes, and probably one of the most important things you're going to learn is how to find your mistakes. But did you guys get this working on your own? Did you do it with a strategy like I did it? Did you get it working, but you had to push the button a whole lot of times before it actually came on? Leave me comments down below and let me know how this thing worked for you. Okay, this has been kind of a little bit more of a tedious lesson, but I hope you guys went through it. I hope you'll leave your comment down below. Think about giving us a thumbs up. Think about subscribing to the channel. Make sure to ring that bell so that you get notifications when the next lessons come up. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.